Good evening, all of you. Some of my friends and some of my students, they asked me to take a video class regarding the various formulae that we come across in business statistics. Today, what I'm going to do is I'm taking a video class, I'm conducting a video class on the various formulae that we come across for business statistics 1. Because in a few days, they are going to write the examination, that is of second year, third semester, they are going to write. And so many students in my college, okay, and so many outside persons also, they asked me, they requested me to take this business statistics formula video class. Okay, and with that, I want to take the video class regarding the various formulae that we come across in this business statistics 1 subject. And this is a privilege for me to take the class on this formulate business statistics 1 formulas. In business statistics, you will have 5 units. Okay, the first unit is completely of introduction. The second unit is diagrammatic and graphical representation. And the third unit is measures of central tendency. That is, we'll take into account the various central tendency values. And we have to go for different formulae for that. And after that, you'll have measures of dispersion. And after that, you'll come across correlation analysis. So when you take into account all these things, you'll come across so many formulae, and some people, they are telling that, sir, we cannot able to remember. Okay, even though we used to forget everything. So when you hear everything, okay, when you hear and when you concentrate, automatically you'll come through this formula, because we don't know what type of problems they are going to give and what type of problems we have to use. Whether the problem may be big or small, it's irrelevant. But when we come to know about the formulas, okay, when we come to know about the formulas, we can able to handle the problem with an easy risk, with an easy task, and with a less risk aspect. That's why I'm doing this video for those people who requested me to do this. So first of all, I'm not taking into account the other units, that is the fundamental, the starting introduction and other topics. I'm starting from measures of central tendency and giving different formulas. When we go for measures of central tendency, we'll come across, okay, first thing is average, that is arithmetic mean. When you go for arithmetic mean, it is just equivalent to the simple average that we come across in our primary studies. So what are the formulas that we come across and what are the things that we see in this arithmetic mean? All these things I'm going to tell you regarding the formulas. Okay, now when you start this measures of central tendency, what is a measure of central tendency? Measure of central tendency is nothing but a representative value of a given data. We'll come across different data information, and from that data, the information, whatever it may be, the representative value, we have to take into account that thing and we have to do that. Okay, when you go for measures of central tendency, measures of central tendency is equal to the average, what we learn in our primary classes. Okay, when you take into account average, sum of items by number of items. Sum of items by number of items is nothing but the average that we come across when we go our primary classes. Now, when we go for statistics, here measures of central tendency, there are 5 types. Okay, there are five types. Okay, first one is arithmetic mean, second one is median, and third one is mode, and fourth one is geometric mean, and the last one is harmonic mean. So all these averages, all these things, okay, they will have different formula. They will have different formula, and we have to take into account that formula, and we have to use that. Whatever it may be the problem, whether it may be a small problem or a big problem, you have to apply that formula. So thereby you will get the answers in a very easy manner. And before going to this measures of central tendency, all the people, all the students, they must know that when we go for statistics subject, compulsory we will come across three important series. Those are individual series, second one is discrete series, and third one is continuous series. These series you will come across compulsory in any topic, whether you take arithmetic mean, whether you take geometric mean, whether you take harmonic mean, whether you go for mode, median, whatever it may be the measures of central tendency, whatever it may be the measures of central tendency, you will come across these three types of series. Okay, when we go for arithmetic mean, we'll have two types of arithmetic mean: simple arithmetic mean and weighted arithmetic mean. So what is simple arithmetic mean? First of all, we'll learn. And okay, in how many series will come across, and what are the different methods that will come across in this individual series, discrete series, and continuous series. Okay, when you go for simple arithmetic mean, individual observations or individual series, okay, bar x or x bar, anything you can call that, or bar x or x bar. So that is the symbol that will keep for arithmetic mean. Bar x is equal to sigma x by n, where x is equal to x1 plus x2 plus x3 plus etc xn by n. So this is the first formula that we come across when we go for individual series, that too direct method. And sometimes, okay, we'll come across shortcut method or indirect method. There we have to take into account assumed mean. That is, we won't get the arithmetic mean directly. We have to calculate the arithmetic mean. So in order to calculate the arithmetic mean, we have to take one value as assumed mean. That is, we have to think that it is nothing but the mean value, but it is not the correct mean value. So assumed mean we have to take into account. And the formula for this arithmetic mean in individual observations, okay, regarding the shortcut method is bar x is equal to na plus sigma d, or bar x is equal to a plus sigma d by n. Okay, where d is equal to deviations taken from assumed mean. Okay, whatever it may be the assumed mean that we take, okay, from the data, we'll take the deviations. And this assumed mean, you can take any number. Okay, there is no hard and soft rule that you have to take the data what it was given. You can take any number as assumed mean, and you can take deviations. But generally, people, what they will do is, from the data only, they will assume one value as arithmetic mean, and they'll calculate the deviations. So this is the formula that we'll come across for the shortcut method in individual series. Now coming to the second series, that is discrete series. There you will also come across two methods: direct method, shortcut method, or indirect method. So when we take into account discrete series, one thing you have to observe here is, in individual series, we won't come across frequency, that is number of occurrences of that data. But when we go for discrete series, compulsory we have to take into account the frequency, that is number of occurrences of the data. So you will have the data as well as frequency. So in direct method, what is the formula? Okay, bar x is equal to sigma fx by n. That is variable value into corresponding frequency. So we have to take into account that corresponding frequency and divide by n. So bar x is equal to sigma fx by n. N represents sum of frequencies. That is, you can take that as sigma f or n, anything. Okay, this is the formula that you will come across for discrete series in indirect method. Now, when we go for shortcut method, okay, whenever you come across shortcut method, you have to take into account that we are going for assumed mean. It is not the actual arithmetic mean, please. We are taking one value as the mean value, and we are doing that. So shortcut method or indirect method, wherever you come across, okay, keep that in mind that we have to take assumed mean. And this assumed mean, it is represented by A. So the shortcut method or indirect method is bar x is equal to A plus sigma FD by N. So we'll take deviations from arithmetic mean. That is from the variable value to the assumed mean, whatever it may be, the deviations or differences that we come across, we'll take that. And that deviations, they must be multiplied by the corresponding frequencies. So automatically you'll come across FD. So when you add all these FD values, you'll come across, okay, sum of FDs. That is bar x is equal to A plus sigma FD by N. Okay, this is a shortcut formula, shortcut method for calculation of arithmetic mean. Okay, so after this, we are going for the continuous series. That is the third series that we will come across. In this continuous series, we'll come across three methods. Okay, direct method, shortcut method, and step deviation method. So what is this three methods in continuous series? When you go for continuous series, keep that in mind that you will come across class intervals, that is classes, different classes with a common difference or class interval. Okay, it may be 10 or it may be 5 or it may be 4 or anything. And when the classes are in equal way manner, that is 0 to 10, 10 to 20, like that, okay, whatever it may be, the difference that we come across between the lower limit of the class and upper limit of the class, we'll call that thing as class interval. And when the classes are unequal, we have, instead of writing I, okay, instead of writing I, that is, we will represent the class interval with the letter I. Instead of writing I, we use C, that is common difference. So that is the difference between the I and representation of I and C. So here also you'll come across three methods. Those are direct method, shortcut method, and step deviation method. So what is direct method formula, and what is shortcut method formula, what is step deviation formula? When you take into account the direct method formula, bar x is equal to sigma fm by n. So we have, when we are coming across classes, we have to take into account the mid values, and the mid values, they will be represented by m. Okay, so f into m, that is product of mid values with their corresponding frequencies, So it will become fm. Okay, so bar x is equal to sigma fm by n. Here you can write n or sigma f, anything is one and the same. Okay, they will represent the same meaning. So mid values we have to take, and we have to multiply the mid values with the corresponding frequencies, and after getting, we have to total them, thereby you will get sigma fm, and you have to add all the frequencies. That thing will give you sigma f or n. Okay, so you have to take into account this thing. Okay, okay, and how to find out the mid value? Lower limit plus upper limit by 2. This is the formula that you will come across. That is, mid value or midpoint is equal to lower limit of the class plus upper limit of the class by 2. That is, we have to take the average of lower limit and upper limit. Okay, this is about the direct method formula. Now coming to shortcut method or indirect method. Okay, the formula here also we have to take into account the assumed mean. Bar x is equal to A plus sigma fd by n. Here we have to take one value as assumed mean, and we have to take deviations, and we have to multiply the deviations with their corresponding frequencies, thereby you'll get FD, and we have to total the FD, thereby you are going to get sigma FD, and after that you have to add all the frequencies, and that will give you sigma F or N. That is the second method that we will come across. And the third method is step deviation method. You see, when we go for this assumed mean, sometimes we'll come across, okay, big number of deviations, that is large number of deviations. Okay, this large number of deviations, when you want to curtail, when you want to cut down, you have to divide the deviations with the class interval, that is I. Okay, and that thing, it will be represented by D dash. Okay, D dash. So that thing also you have to take into account. Sir, when will come the original value? Okay, when you are dividing with class interval in the first instance, after getting, you have to multiply with class interval. Thereby you are going to get the correct value. So the formula is bar x is equal to a plus sigma fd dash by n into I or C, anything. Okay, anything. I told you already that when the classes are equal, we have to represent I. Okay, and when the classes are unequal, we have to represent by C, common difference. So this is a step deviation formula. Okay, here we have to find out the deviations divided by class intervals. That thing, it will be D dash, and this D dash and frequency, when you multiply and when you total that, you'll come across sigma fd dash. Okay, this is the third formula for calculation of arithmetic mean. Okay, next, after that, you will come across weighted arithmetic mean. So what is this weighted arithmetic mean? Okay, the weighted arithmetic mean is, we'll take into account the weights. We'll take into account the weights, and we have to multiply the variable values with the weights, and we have to total that. So thereby we'll get the weighted variables. Okay, the formula for that is bar x w, that is w will represent weighted arithmetic mean. So bar x w is equal to sigma x w by sigma w, that is we have to add the weights and we have to divide with that total weights. Okay, so this is the formula. And another thing is, after this you'll come across the calculation of arithmetic mean of two groups as well as three groups. So when you are going to calculate the arithmetic mean of two groups or three groups, we'll call that thing as combined arithmetic mean of two groups and combined arithmetic mean of three groups. So combined arithmetic mean of two groups, the formula is bar x 1 2. You should not call that as 12, please. Bar x 1 2 is equal to n1 bar x1 plus n2 bar x2 by n1 plus n2. So here n1 is, okay, number of observations of first group, and bar x1 is equal to arithmetic mean of first group, n2 is equal to number of items of second group, and bar x2 is equal to number of items of second, the number, I mean arithmetic mean of bar x2 is equal to arithmetic mean of second group. So n1 plus n2 is equal to total of the two groups, and this thing you can extend for three groups also. So when you want to calculate for three groups, bar x 1 2 3, you have to, don't call that as bar x 123. You have to call that as bar x 1 2 3 is equal to n1 bar x1 plus, that is n1 into bar x1 plus n2 into bar x2 plus n3 into bar x3 by n1 plus n2 plus n3. So this is the combined arithmetic mean of three groups, and this will come across when you go for mathematical properties of arithmetic mean. And this is regarding the arithmetic mean formulas. Okay, now after that we are going for the second measure, that is nothing but median. Here when you take into account the measures of central tendency, there you'll come across two measures as positional averages and three measures as calculated averages. So median is nothing but a positional average. When you go for positional average, okay, we have to take into account the center value and through that value we'll represent the representative value. So median is nothing but the middlemost point of the given data. So here also you'll come across individual observations, discrete series, individual series, discrete series, and continuous series. When we go for individual series, first of all, what we have to do is we have to arrange the data either in ascending order or in descending order, either in ascending order or in descending order. So after arranging the data in either in ascending order or descending order, we have to apply the formula, that is median is equal to size of n plus 1 by 2th item for individual series. Because sometimes the n value will be the even number, and sometimes the n value will be odd number. So in order to remove that odd and even numbers, okay, in order to remove the differentiation, we have to take into account plus 1, and we have to add the plus 1 to that n value. So that is the formula that you will come across for median under individual series. Size of n plus 1 by 2th item. Okay, then after that, okay, what is the value that you got? You have to take into account the data, and that value will be the median value. So that's why median value is nothing but a positional average that we will come across. Okay, this is regarding individual series. Now coming to discrete series. Same, in here also we have to arrange the data either in ascending order or in descending order. And here, when we go for discrete series, compulsory will come across frequencies. So when we are coming across frequencies, the first step that you have to do is you have to prepare the cumulative frequency. So what is this cumulative frequency? Cumulative frequency is nothing but an added frequency. And the simple frequency, it will be in irregular form. That is, it will start with small number, and in the middle you will come across a big number, and again it will decrease, it will come down to a small number. So there won't be any uniformity in simple frequency. When you go for cumulative frequency, you will come across a uniformity. That is, it will start with small value and gradually it increases. So the first step that you have to do is you have to prepare the cumulative frequency, and you have to apply the formula. Same, median is equal to size of n plus 1 by 4th item. And you have to see the size of that in the cumulative frequency. Okay, mind it, you have to see that in the cumulative frequency, and corresponding value, whatever it may be, the corresponding value, it will be the median value in discrete series. So people, they must be very careful and very cautious when they are going for discrete series. And coming to continuous series, okay, in continuous series, we all know that we'll come across classes. We all know that we'll come across classes. So there is no necessity for us to add one over here. Okay, so what we have to do is we have to apply the formula size of n by 2th item. Okay, here also in continuous series, what you have to do is, first of all, you have to take the cumulative frequency. That is, you have to prepare the cumulative frequency. And then you have to follow the formula size of n by 2th item. And whatever it may be the value, that is, whatever it may be the size, you have to see that in the cumulative frequency, and corresponding value, corresponding class will be the median class. And there you will come across the median class, but you won't come across the actual median value. So in order to get the actual median value, you have to use one more formula, that is nothing but interpolation formula. And what is this interpolation formula? Okay, the interpolation formula is median is equal to L plus n by 2. That is whatever you have done earlier, that n by 2 minus CF. What is this CF, sir? Cumulative frequency preceding the median class. Before the median class, whatever it may be, the cumulative frequency that we come across, we have to take that. Okay, so L plus n by 2 minus CF by F, that is simple frequency of the median class, into I. I is nothing but the class interval. So don't forget this. Okay, compulsory. You have to go for interpolation formula when you go for continuous series in order to get the median value, perfect median value. In order to get that, you have to use this interpolation formula. And apart from median, we are having some other related positional averages like octiles, deciles, okay, percentiles. So what is octiles? Okay, when you divide the data into 8 equal parts, okay, okay, first before octiles, you will come across quartiles. Sorry, before octiles, you will come across quartiles. What is this quartiles? When you divide the data into 4 equal parts, leaving one part and considering the other 3 parts is nothing but the quartiles. That is, there you will come across Q1, Q2, and Q3. So we won't consider the last part. That is 25%, 50%, and 75% of the data only will take into account. So this Q2 is nothing but the median value. Whatever it may be, the median value that we come across, it is equivalent to the Q2 value because we are taking 50% of the data. So here, what we have to find out is Q1 value as well as Q3 value. There also, you will come across individual series, discrete series, and continuous series. So this thing, you must be very careful and you must observe every time, okay, whether we'll come across individual series, whether we are given individual series, discrete series, and continuous series. Individual series, 1 to 2 times I'm telling that individual series, when you come across, you will come across only the data, the raw data only you come across. You won't come across the frequency of number of occurrences of that data. But when we go for discrete series, along with the values, variable values, you'll come across the frequency, that is number of occurrences of that value. So you'll come across data and frequency in discrete series. And when you go for continuous series, okay, it is obvious that you'll come across classes as well as frequency. So this is how you have to take into account. When we go for Q1 in individual series, okay, the formula is size of n plus 1 by 4th item, because we are dividing the data into 4 equal parts, leaving one part and considering the other 3 parts. So as we are dividing the data into 4 equal parts, you have to divide with 4. So n plus 1 by 4th item. So whatever it may be the size, okay, corresponding value for that will be the quartile, first quartile value. And the first quartile, it will be represented by Q1. Okay. Now coming to third quartile in individual series. So the formula is Q3 is equal to size of 3 into n plus 1 by 4th item. 3 into n plus 1 by 4th item, because we are taking into account the third quartile. So you have to multiply with 3. Okay. So whatever it may be the size, corresponding value, okay, will be the quartile, third quartile value. So like this, you'll come across in individual observations. And when you go for discrete series, there what we have to do is, okay, first of all, you have to prepare the cumulative frequency. Okay, after preparation of cumulative frequency, you have to use this formula, that is size of n plus 1 by 4th item. And that size of the item, whatever you come across, you have to see in the cumulative frequency, and corresponding value will be the Q1 value or first quartile value. Now, next, third quartile value. Okay, same size of 3 into n plus 1 by 4th item. Okay, don't be of that opinion that we have to take frequencies over here. Okay, frequency we should not take. Whatever it may be, the variable value that we are given, we have to take that thing only. But you should not consider at all the frequency. So size of 3 into n plus 1 by 4th item, you'll get some size. And that size, you have to see that in the cumulative frequency, and corresponding value will be the third quartile value. Like this, you will come across in, okay, discrete series. Now coming to continuous series. In continuous series, we'll come across the classes as well as frequency. So there, okay, same. Q1 is equal to, the formula is Q1 is equal to size of n by fourth item. There is no necessity for us to add 1. Like how we did in individual series and discrete series, we should not add 1. So directly n by fourth item, size of n by fourth item. And that value, whatever it may be, the size that we come across, we have to see in the cumulative frequency, and the corresponding class for that cumulative frequency will be the first quartile class. Okay, there you will come across only the class place, but you won't come across the value of first quartile. So for that also, you have to use the interpolation formula, and that interpolation formula is, okay, Q1 is equal to L plus N by 4 minus CF by F into I. Okay, so all the people, they know that because already you learned in median. So n by 4, the size of the item, minus, okay, cumulative frequency preceding the first quartile class, that thing will take, and f is equal to simple frequency of the class, and I is equal to the class interval. In the same manner, you have to go for Q3. So when you are going for third quartile, okay, after preparation of the cumulative frequency, you have to apply the formula size of 3n by fourth item. There is no necessity for you to add 1, 3n by fourth item. So you have to locate the size, and you have to locate the size of the value, size of the item in the cumulative frequency. Mind it, always you have to see that in cumulative frequency only, and corresponding class will be the third quartile class. Corresponding value class will be the third quartile class. And in order to obtain the actual third quartile value, we have to take into account the interpolation formula, that is Q3 is equal to L plus 3n by 4 minus CF by F into I. This is the formula that you will come across in continuous series. Thereby, you are going to get the third quartile value. In the same manner, you will come across octiles, deciles, and percentiles. So what are octiles? When we divide the data into 8 equal parts, leaving one part and considering the 7 parts is nothing but octiles. There O1, okay, that is first octile, and O7, it is the seventh octile. So same method, whatever you follow in calculation of quarters, same methods you have to follow both for individual series, discrete series, and continuous series. Okay, now deciles. So what are deciles? Deciles, when we divide the data into 10 equal parts, leaving one part and considering the other 9 parts is nothing but deciles. Okay, D1 for first decile and D9 is for ninth decile. Same procedure, whatever you adopted, whatever you followed in calculation of quarters, the same thing will come. But the thing is, okay, you will come across, instead of Q1, you will write D1. Instead of Q3, you will write D9. So that is the thing. So what ninth decile, you have to multiply with 9. Eighth decile, you have to multiply with 8. So the procedure is one the same. It won't change. In the same way, when you go for percentiles, okay, when you go for percentiles, there also, when we divide the data, whole data into 100 equal parts, leaving one part and considering the 99 parts is nothing but percentiles. And the same procedure, whatever you have adopted in quartiles calculation, the same thing you have to adopt over here. So whether it may be individual series or discrete series or continuous series. When you go for continuous series, compulsory you have to take into account the interpolation formula. Okay, interpolation formula is common. Okay, whether you go for quartiles, octiles, deciles, and percentiles, the interpolation formula is compulsory in continuous series in order to get the actual values. So like this, we'll come across other related values regarding, okay, other related positional averages. Okay, and after that, we are going for median. Okay, so here, I mean, not median, mode. Mode is nothing but the highest frequency, whatever it may be, the highest frequency that we come across, the corresponding value will become the modal value, modal value or mode. Okay, so by inspection, when you go for this mode, whether you take discrete individual series, discrete series, or continuous series, okay, by inspection, you can locate the mode or modal value. But when we go for continuous series, we will come across modal class. We don't come across the actual value of mode. So there also you have to use an interpolation formula, and that interpolation formula is mode is equal to L plus delta 1 by delta 1 plus delta 2 into I. So what is delta 1? Difference between the frequency of the modal class and preceding frequency. Okay, whatever it may be, the difference that we come across between the frequency of the modal class and preceding frequency. So this is about delta 1. And what about delta 2, sir? Okay, the difference between the frequency of the modal class and the succeeding frequency. That thing we have to take into account. That's why the interpolation formula is mode is equal to L plus delta 1 by delta 1 plus delta 2 into I. I is common, class interval. And this formula can be transformed in another way. Like how? And like what? Okay, mode is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into I. So what is F1 over here? Frequency of the modal class. F0, frequency of the preceding modal class, frequency of the preceding modal class, and F2 is equal to frequency of the succeeding modal class. So the formula, the first formula can be transformed into mode is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into I. This is the value that we will come across when we go for continuous series. Here, these two values, these two formulas, they will come under interpolation formula only. Okay, you'll have two formulas. Okay, one is delta 1 by delta 1 plus delta 2 into I, and the second one is directly taking the frequencies of the modal class, preceding modal class, and succeeding modal class, and doing that. So this is the thing that will come across in mode. And sometimes when we take into account the inspection method, taking into account the preceding and succeeding frequencies, you may not get the correct mode value. So in that case, we have to prepare grouping and analysis table. And what is this grouping table and what is this analysis table? Grouping table means here, when we are going for grouping table, we have to group the frequencies. Here in grouping table, we'll have 6 columns, please. And the first column will be the frequency, whatever it was given. And in second column, you have to group 2 frequencies. That is 1, 2, 3, 4, okay, 5, 6, like that. 2 frequencies you have to group. And you have to write that. And whichever is higher, you have to encircle that. We have to circle that. And in column 1 also, what is the highest frequency, you have to encircle that. Okay. And coming to column 3, leaving the first frequency, we have to group 2 frequencies. That is, first frequency will leave 2, 3, 4, 5, 6, 7. Like that, we have to group 2 frequencies and we have to write. And whatever it may be, the highest frequency there, that total frequency, we have to encircle that. And coming to fourth column, here in fourth column, we have to group 3 frequencies. 3 frequencies. That is 1, 2, 3, 4, 5, 6. Like that, 3 frequencies we have to group and we have to write. And whatever it may be, the highest frequency, we have to encircle that. And coming to fifth column, leaving the first frequency, we have to group, okay, 3 frequencies. That is 2, 3, 4. Okay, 5, 6, 7. Like that, we have to group, okay, 3 frequencies, and we have to write, and whichever is higher, we have to encircle that. And coming to sixth column, okay, we have to leave first 2 frequencies. That is 1, 2, we have to leave. So there also, we have to group 3 frequencies. That is 3, 4, 5, 6, 7, 8. Like that, you have to group 3 frequencies, and we have to write, and whatever it may be, the highest frequency, we have to encircle that. So this is nothing but the grouping table. Then after that, we have to prepare analysis. That is, we have to analyze that. For that, whatever it may be, the data that was given, we have to write horizontally, and whatever it may be, the columns that we have taken, we have to write, okay, vertically. And in first column, which data is having highest frequency, we have to mark, okay, a 1. We have to mark a bar in that. And in the same way, okay, what data or what classes they make the highest value in second column. For that also, you have to make 2 1s, that is bar. You have to write 2 bars. Okay, for 2 values, you have to write 2 bars. So like that, for 6 columns, you have to write, and you have to add that. So there, after totaling, okay, we'll come to know which class or which data will show highest number. So that corresponding value will become the modal value when you go for discrete series. And when you go for continuous series, you will come across the modal class. Okay, and thereby you can do the interpolation formulas, whatever I had already told. Okay, with that, you'll come across the modal value. Okay, sometimes what will happen is, you'll come across 2 values same. When you are preparing the analysis table, you'll come across the total one number 2 times. Then we can say that it is, okay, bimodal distribution, or we can say, in other words, the mode is ill-defined. When mode is ill-defined, okay, we cannot able to calculate by interpolation formula. There, what we have to do is, we have to apply an empirical formula. Okay, we have to apply an empirical formula. What is this empirical formula? 3 median minus 2 mean. 3 median minus 2 mean. There, you have to calculate median value, and at the same time, you have to calculate the mean value. And this median value you have to multiply with 3, and the mean value you have to multiply with 2. So you have to deduct from 3 median to mean value. So thereby, whatever it may be, the quotient or whatever it may be, the result that you come across, it is nothing but the mode value. So like this, you will calculate the modal value. Mode is nothing but that value which will have highest frequency, or which will repeat highest number of times. That is nothing but mode. Okay, this is the third measure that you will come across. And after this, you will come across geometric mean. Okay, there, when you go for arithmetic mean, it is summation of the values, summation of the items by number of items. But in geometric mean, it is not like that. Okay, nth root of product of n items. Nth root of product of n items. That is x1, x2, x3, etc. If you are given 2 numbers, square root. If you are given 3 numbers, cube root. If you are given n numbers, nth root. So geometric mean is defined as nth root of product of n items. So generally, when we go for this root, when the number of items, when they are small, we can easily calculate the square root. But when the number of items, when they are large, it is highly impossible for us to calculate the square root. So that's why what we have to do is, we have to use the logarithms. Logarithms are nothing but the easy way for conversion of multiplication as well as division into addition and subtraction. When you are multiplying the values, that thing, it will be converted as addition when we go for logarithms. And when you are dividing, that thing, it will be converted as subtraction in logarithms. So we have to use the values mean. We have to use the logarithms for this geometric mean. So that's why arithmetic mean, geometric mean, and harmonic mean, they are nothing but the calculated averages. Okay, mode and median, they are nothing but the positional averages, whereas geometric mean and harmonic mean are nothing but the calculated averages. So instead of using square root, okay, we'll replace that square root with the log values. And what is the form? What are the formulas that we come across in individual observations, discrete series, and continuous series? The first thing is when you go for individual series, okay, the formula is geometric mean is equal to anti-log of sigma log x by n. So we have to take into account the log values of every value, x value, and we have to add that. So that will give you the sigma log x. And how many number of items will come across, we'll take that days. That is nothing but n. So geometric mean is equal to anti-log of sigma log x by n. So we'll take the log x values and we'll divide with number of items. So you will get some value. And when you want to bring that log values to the original values, you have to go for anti-logarithms. So that's why anti-log of sigma log x by n. That is the formula when we go for individual series. When we go for discrete series, GM is equal to anti-log of sigma f log x by n. Okay. So what is this f log x by n? Okay, whatever it may be, the log x values that we come across, that we prepare, okay, we have to multiply with frequency. So thereby you will get f log x, and you have to add all those things. So when you add all those things, you'll get sigma f log x. And by adding the frequencies, you'll get the sigma f or n value. You have to divide that sigma f log x value with number of observation, that is sigma f or number of items. So thereby you will get some value. And in order to bring that, okay, to the original value, we have to go for anti-logarithms. Okay, this is the formula that we come across in discrete series. Now coming to continuous series. Okay, continuous series. GM is equal to anti-log of sigma f log m by n. There, okay, you have to, in continuous series, we will come across classes. So you have to take into account the mid values, and for that mid values, you have to see log values. Okay, you have to see log values, and that log values, okay, they must be multiplied with the corresponding frequencies. So you will get f log m, and after adding all those things, you will get sigma f log m. Here, one thing, sir, you are telling that sigma always. What is this sigma stands for? Sigma stands for summation or total. Sigma stands for summation or total. Okay, this is how you will come across the geometric mean in continuous series. And the same way how we are calculating weighted arithmetic mean, we can also calculate the weighted geometric mean. Okay, there geometric mean is equal to anti-log of sigma w log x by sigma w. Okay, there what you have to do is, okay, you have to see the log values, and that log values you have to multiply, you have to find out the product with the respect and the corresponding weights. So thereby you'll get w log x, and by adding all these values, you'll get sigma w log x, and that thing you have to divide with total weights. Okay, so automatically you'll come across the weighted geometric mean value. Okay, so this is the fourth measure that we come across. And the last one is harmonic mean. Here, when we go for harmonic mean, we have to take into account the reciprocals of the values. So what is the reciprocal? What is the reciprocal? Reciprocal is nothing but the smallest value that we derive. And how we'll get the smallest value? When we divide 1 with the respective values, it is nothing but reciprocal. That is 1 by anything is nothing but reciprocal. Thereby what is happening is we are getting the lowest and the last thing. that we come across. So in individual observations also, you'll come across harmonic mean. Okay, discrete series harmonic mean, continuous series harmonic mean. Okay, so what are the formulas that we come across? Harmonic mean will represent that as H dot M, harmonic mean. Harmonic mean is equal to 1 by 1 divided by, okay, 1 by X. So there we are taking into account the number of items. So the formula will be, instead of going for 1, we have to take into account n by 1 by x. I told you that reciprocal is nothing but the smallest value. When you divide 1 with that value, it is nothing but reciprocal. So how many items we are taking, we have to take into account. So n by 1 by sigma 1 by x. Sigma 1 by x. First of all, you have to take into account the reciprocal, and we have to take into account. In discrete series, okay, the formula is n by okay, sigma f by x. That is, we have to take reciprocals and we have to multiply with frequency. So you will come across f by x, and we have to add that. So it comes to sigma f by x. So number of items, that is total frequency, we have to divide with this sigma f by x. This is the formula to calculate harmonic mean in discrete series. Now coming to continuous series, harmonic mean is equal to n by sigma f by m. In continuous series, what we will do is we have to calculate the mid values, and we have to multiply the reciprocals of mid values, and after that we have to multiply with frequencies. Thereby you'll come across f by m. So all these things you have to add. So you'll come across sigma f by m, and the total observations, whatever it may be, the total things, frequencies, total frequencies, we have to take into account that thing, and we have to divide with this sigma f by m. So this is about the measures of central tendency, various formulae that will come across. In the next class, I'm going to take into account the measures of dispersion. In measures of dispersion also, you'll come across different formulae, and okay, taking into account the problem given, we have to use that formula. Okay, don't be of that opinion that every formula will suit to every problem. Basing upon the problem, whatever it had given, whatever it was given, you have to take that formula and you have to use that. So you must be very thorough with this formula in business statistics 1 paper. Okay, all the people, all the students, I am just requesting and to get through all the formulae, even in midnight. If you are vacant, if you wake up and if you are asked any formula, you must be in a position to tell that. That is, every formula, it must be at your tongue tips. Please mind that. Okay, suppose if you say that we cannot able to write, read 10 times, and then write 1 time. By seeing, don't go for closing the book and writing. By seeing that, just write 1 time. Automatically, you will come to understand about all the formulas. Thank you.